Another way of representing sets of numbers is using interval notation. It's really easy. It's a very quick way of representing numbers, but only representing the real numbers. So you're only allowed to write it if it says it's the element of real number, if it's a set of real numbers. And this is what it looks like. That's an example of interval notation. Here we've got -3 and 5. And quickly point out, smaller number on the left, bigger number on the right. So you only write it with two numbers, and they've got very special brackets. These round brackets or braces show that the number is not included. If it is a square bracket, it looks like this one here, then the number is included. So if we're reading this set of real numbers, we'd say the real numbers greater than -3, because the bracket looks like this, it's not included. The real numbers greater than -3 and less than or equal to 5. A special thing here, that's our symbol for infinity or negative infinity. Numbers go on and on and on and on. So if I said the real numbers greater than or equal to 1, then we'd say 1 greater than or equal to, sorry, I said it's greater than or equal to, use a square bracket. And where will they end? They'll end at infinity. And when we're working with infinity, infinity is always not included. Or if I had negative infinity on the left-hand side here, then I would use a brace or a round bracket to show it's not included. Let's work through some examples. Here's an example of interval notation, of set builder notation. In this set builder notation, it says at the end, x is the element of real numbers. So we can write that easily using interval notation. It says x in the middle here is greater than or equal to 0, but less than 4. So it's already given me my two numbers, 0 and 4. Start by writing them, 0 and 4. It says x is greater than or equal to 0. So it can be 0. 0 can be included. So I'm going to use a square bracket to show that it can be included, but it's less than 4. Not equal to, it's less than. So on that side, I do my round bracket, showing it's not included. Or if I'm given another example in set builder notation, x is the element of real numbers, so we can write it in interval notation. Reading the middle part here, the mouth is opening to x, so x is greater than 1. If I look at those numbers greater than 1, I'm looking at 1, 2, 3, 4, 5. Where's it going to end? It's going to end at infinity. So here's my two numbers, 1 all the way to infinity. We write them down, 1 and infinity. This says x is greater than 1. So it's not included, it's greater than 1. So we use a round bracket to show it's greater than 1. And we start out the video saying infinity is always not included, or always a round bracket. This one again, x is the element of real numbers, so we can write it in interval notation. Reading the middle part, and knowing that the mouth always opens to the bigger number, this says x is less than or equal to -1. In other words, it's the numbers going down. There's -1, getting smaller and smaller and smaller, -2, -3, on and on and on, all the way to negative infinity. So when we're working with the two numbers, the smaller one goes on the left-hand side. So negative infinity then be there, and -1 will be here. And we said when we work with infinity, started out the video saying infinity is always not included. So round bracket shows not included. And then the statement, x is less than or equal to -1. So it can be -1. Use a square bracket. The real numbers, so we can do interval notation, greater than 6 and less than or equal to 15. So our numbers here are going to go from 6 to 15. So we can write those two numbers in the middle, 6 and 15. The real numbers greater than, so it's not included, we use a round bracket, but less than or equal to 15, so it can be 15, 15 might be included, so we use a square bracket. And the last one is all the rational numbers between -4 and 9. They're rational numbers, and we said only real numbers can be written in interval notation. So if they tell me it's the rational numbers, then I can just say, well, it's not applicable, I can't write it in interval notation. go through these, work on them, make sure it's real numbers, make sure you know if it's not included, we use round brackets. If it is included, square brackets. Once you learn that and you make sure it's a set of real numbers, pretty straightforward, you can do this.